We're going to be looking at solving systems equations. This first lesson has been called Guss and Das House, talking about Gaussian elimination. And we're going to start off with the first part of this, just going over graphically and algebraically when we're looking at solving systems of equations. So the first one we're going to do is ones like you did in algebra, just to remind us of how we solve. So when we're solving using substitution, the goal is to get one letter isolated. So we're going to try to get y isolated. And so that means we have everything in terms of y. So 2x plus y is equal to -6. And so when we move things around, we want to move that 2x to the other side. And when we cross that wall, it changes operations. So it does the opposite operation. So addition becomes subtraction. And so that gives us that y is equal to -2x minus 6. And I like these in order with the variable first. It keeps us in a system of being organized and keeps you from making more mistakes. We're going to substitute everywhere we see a y, that equation. So when we're looking at this next one, we're going to look at that y and we're going to replace it with that -2x minus 6. So let's look at the equation. -5x plus 4 times our y is equal to -11. And that y was -2x minus 6. So step 1 is going to be distributing. So -5x plus -8x minus 24 equals -11. Next step is going to be to combine like terms. So look at our like terms, combine those, we end up with a -13x minus 24 equals -11, because we haven't done anything there. Now that we have the left-hand side all situated, we now need to cross the wall and move things around. So we're going to move that -24 by using the opposite operation over to the other side. So we're going to add 24. And so that gives me that -13x is equal to a +13. Now we need to separate that -13 from the x. So we're going to divide both sides by -13. And so therefore, x is equal to -1. So we talked about yesterday that these are going to meet, and they're going to meet up at an order pair. So we have an x. We need to find out what the y is. And so we're going to take that -1 and plug it back into the x. So y is equal to -2 times -1 minus 6. So 2 minus 6 is -4. Y is equal to -4. So my order pair, or my solution, is going to be -1, comma, -4. And this makes sense. We'll solve in, we can plug it into both equations, it'll become true. If you're ever dealing with a story scenario, you need to look and see what was x representing. Was it something that could be negative? What was y representing? Is it something that can be negative? And if the answer is no, this may be a no. This may not actually plug in to be a solution for the story. It's a solution for the equations, but it may not match into the story. So let's take it one step further. So that was the algebra 1. We were looking at systems. We were looking at solving two lines equal to each other. And we talked about that there's sometimes situations where we'll have them being parallel, which means no solution. Another thing is they could be actually overlapping, and that means that they are all the solutions. But here's a unique situation. We have variables involved, and we have them being squared. So we're going to look at it, and this is combining what you were doing at the end of Algebra 1, where you were solving with quadratics and what you did at the beginning, which was solving systems. So again, you want to look at which of these two equations is going to be the easiest for us to solve for a letter. I think equation 2 is going to be the easiest. So I'm going to take equation 2, and we'll write it down. X minus y is equal to 0. And my goal is to get one of the letters by itself. Well, I'm going to get x by itself by moving y over. And x is equal to y. So this is really simple. There's nothing being added here. So every time I have an x, I can write a y in its spot. Or every time I have a y, I can write an x in its spot. I'm going to choose to substitute all x's for y. So I have something squared plus y squared minus 6 times something minus 4y minus 48 is equal to 0. So everywhere I saw an x, I'm putting that y in its spot. So each of those somethings that I was looking at is going to be y. So y squared plus y squared minus 6y minus 4y minus 48 is equal to 0. Combining like terms, we end up with 2y squared minus 10y minus 48. And at this step, always ask yourself, is there something that can divide into all of those equally? And the answer is 2. It has to go into everything, including this other side. So 2y squared divided by 2, negative 10y divided by 2 is going to give us minus 5y. Negative 48 divided by 2 gives us a negative 24. And 0 divided by 2 gives us 0. Now, when there's a quadratic involved, you need to have all the letters on the one side, all the variables on one side, and all the numbers on one side. And then you're going to solve either using quadratic formula, or you can solve using the box method to factor. And so remembering back to the box method, when y'all talked about factoring in Algebra 1, you put your squared term in this corner, negative 24 in this corner. You look to see what would multiply to give you 24y squared, but will add to give you negative 5y. So because this is a negative 24, they're going to be opposite signs. Oops, that's not what I was trying to write. And they are both going to have a y because we're trying to get y squared. So two things that multiply to give me 24. 6 and 4. Well, that gives me a sum of positive 2y. So that did not work. And I realized that's going to be a positive anytime I put my larger one on with the positive. So I'm going to do it the other way around this next time. The next two factors I can think of that would multiply to give me 24 is negative 8 and positive 3. Negative 8 plus 3 is going to give me a negative 5. So that gives me negative 5y. So that worked. Now, it doesn't matter the order I put them in over here, but I need to put in the negative 8y and the positive 3y. Now, when we're looking at factoring, we look to see what can factor out of this first column. A y can. We can factor out of the second column. A negative 8 can. We can factor out of that first row. Y can. We can factor out of that second row. 3. And it's positive because the closest is positive. This one was negative because the closest was negative. So I'm going to write those factors. And I'm going to go ahead and erase my work here so I can work underneath it to solve the next step. So what I know on this is that either, first I have a product of 0. Either this first one has to be 0 or this next one has to be 0. So it's either y minus 8 that's equal to 0 or it is y plus 3 that's equal to 0. And so I'm going to solve for that y. And so y, I need to move the 8 over to the other side. And so y is equal to positive 8. And based upon what we did earlier, I know that x is equal to the same thing as y is. And so x is equal to 8. And so my order pair is 8, 8. On the other one, we're going to again solve it for y. We're going to move the 3 over this time. So negative 3, negative 3. And so y is equal to negative 3. And so I have, again, that equation from above said x was equal to whatever y was. And so we have negative 3, negative 3. And again, evaluate based upon where did these equations come from? Was there a reason that we couldn't have negatives? Or could we not have positives? And if that's the case, you may be able to knock out one of these two solutions based upon the story itself. We're going to go further into this tomorrow. So we'll stop here, and then the next lesson we'll continue on where we stopped.